Hello, and welcome back to CS631 Advanced Programming in the UNIX Environment. In this video, we'll take a look at the Sizeof operator, because I've noticed that a lot of students tend to erroneously consider it to be the same as strlen. That is, I see a lot of code where Sizeof is used to determine the size of a buffer, which, sounds kind of like what something called Sizeof might do. And in fact, even the strlen copy manual page provides example code using exactly Sizeof as shown here, whereby it explains that precisely because strlen copy does not write a null byte, one should use code like this, where we ask it to not write more than sizeof buff minus 1 bytes, and then we set the null byte in the buffer ourselves. But note that here we are using a fixed size buffer, a buffer with a size that is known at compile time. But very frequently we have code that looks perhaps more like this, where we use a simple pointer to some area memory that we have allocated via, say, malloc. If we now use sizeof here, we're going to have a problem. We may not notice it at first, but this code is inherently flawed and risky. But why? In order to understand that, let's take a look at what Sizeof really does. Now, spoiler alert, Sizeof is an operator, not a library function, so there is no manual page. So how do we find out about how Sizeof behaves? Let's simply observe it using the lessons we learned in week 5 using the debugger. That is, we can use an empty program and run that in the debugger, break in main, and we kinda get a REPL for C. Neat, huh? Anyway, so here we go. Let's start out with the basics. What is sizeof char? Sizeof char is 1. That is, sizeof gives us the storage size of the data type we pass it in char-sized units. Logically then, that sizeof char is exactly 1 char-sized unit. How about an int? Now, on this platform, an int is 4 bytes. A float is 4 bytes. A long is 8 bytes. And a double is also 8 bytes. So far, so good. These are basic data types in C. What else do we have? Well, we have pointers. What's the size of a pointer? 8 bytes. And there really isn't a difference between a char star and a void star. Both are pointers, which are memory addresses, which are 8 bytes on this platform. Okay, so let's write a simple program that will tell us all the sizes of the data types we have. Here we go. Float, double, char, and pointers. Those are easy. But in C, we can also create our own data types, right? That is, we can define a struct. What is the size of a given struct? Here, we have a program that defines a few structs. One comprising a pointer, one with a pointer and an int, one with 2 ints, and finally a struct of structs. Let's inspect this program. We break in main and run it. What's the size of our struct1? Well, our struct1 only contains a pointer, so not surprisingly, the size of struct1 is going to be 8. Now, sizeof does not require the data type as an argument, but can also be given an expression. So if we have a variable of type struct1, then we can just say sizeof as 1 and get the same size. How about struct2? A struct2 contains a pointer, 8 bytes, and an int, 4 bytes, so we might expect it to return 12 bytes. But structs may be padded, so it looks like we'll get 16 bytes here to include padding to improve alignment in memory. Okay, so struct 3 contains 2 ints and a pointer, so it fits in with the alignment just like struct 2, 16 bytes. And what about struct 4, a struct containing other structs? Well, that contains a struct 1, 8 bytes, a struct 2, 16 bytes, and a struct 3, 16 bytes, adding up to 40 bytes. Let's add all this to our program. Here we go. Basic data types as well as structs. But now we're going to get a bit funky. In C99, we got support for flexible array members in structs. That is, we could have a member in our struct that is an array of an unspecified size. So what would be the size of this flex struct? Let's take a look. Sizeof struct flex returns 1, which is the size of the char C. That is, the array member appears to have a 0 size in this struct. So if we instantiate 2 of these structs, we get structures with a char C and an empty array. Now we start using strncopy to write to f2.array, and we can confirm that we successfully wrote the data. But now, if we look at f1 again, we notice that we apparently overwrote that data structure. Since we're on the stack, f1 has a higher address than f2, and since the size of the struct is 1, f2 begins right below f1, and our writing flex ended up writing f into the char element of f1, and lex into its array. Now this is clearly the wrong approach. How should we initialize such a flex array? f3 is a pointer. So maybe we can just write data to that. What's the size of f3? Well, it being a pointer, Sizeof returns 8 and is initialized as null. So of course, if we then try to write data to f3.array, we, well, get a segfault because we attempted to dereference null. Let's try this again, this time using a different approach. Here we continue until we're back at writing to f3. But this time we had initialized f3 using malloc. So now f3 is a valid pointer with a struct found at this memory address. So now we are successful in writing our data into the flex struct. But the size of f3 remains 8 because f3 is still just a pointer. But now things are getting really weird. f3 has a field named array, which contains the string flex. but f3 array is size of 0. Remember, we had defined the struct as containing a zero-sized flex array, so Sizeof dutifully reports that size. But the data found in that array has a string length of 4 for flex. So clearly there's a difference between Sizeof and strlen, right? Let's investigate this difference. Here's a new program that we start right away in the debugger. The program looks like this. We initialize a few buffers and pointers, allocate some memory, write some data, and, well, let's see. So, what is buff1? Well, it's ABC. What is the size of buff1? It's 4. 3 letters plus a terminating null character makes 4. What is its string length? strlen returns the length of the string up until the terminating null. So that's 3. Okay, so we want to inspect the other buffers too. So let's save ourselves some typing and define an alias in GDB to call these two. Let's say sz for Sizeof and str for strlen. There. Okay, so now what's buff2? Buff2 is a char array of size 1024, and Sizeof agrees, 1024 bytes. But what's strlen? That reports as 6. Why is that? Well, we didn't initialize the buffer, so its contents are undefined. It just so happens that the first few bytes are not null, so strlen will count them up until the first null byte it finds, ergo 6. Now, buff3 is different. We had initialized buff3. Buff3 is also a char array of size 1024. And yes, Sizeof agrees that it's 1024 bytes. But strlen will tell us that it is 3 bytes in length, because that is how we initialized it. ABC and an implicit 1020 remaining null bytes. Okay. Now, what is S1? S1 is a char star, and we know the size of a char star is 8. But we had initialized char star to point to the string ABC, so its strlen is now again 3, and P as 1 shows the fixed string here. S2 is another char star, i.e. another pointer of size 8. Its strlen is also 3, because S2 points to buff3, which is a char star of 1024 bytes at this memory location over here. Next, S3. Another char star. Size 8 and strlen also 8, but by coincidence, because again we had not initialized S3, so whatever happens to be at that memory location will be reported as its strlen up until we encounter a null byte. Now, where were we? Yes, we're going to allocate some memory. So now, after the malloc call, but before the strlen copy, S3 will now point to a different location. It's still a pointer, so still 8 bytes in size. But its strlen is now 0, because malloc appears to kindly have initialized the memory as L0. If we now write data to S3, the contents of S3 are updated. Its size remains unchanged, since of course it's still just a pointer. But its strlen is now 10, as that is the number of bytes we wrote. So we see that Sizeof and strlen are really quite different. And if we put all this together into one program, then we can observe the differences from the basic data types to the structs and flex array elements, to the different string types, accounting for the trailing null bytes, the initialized data, and the final allocated and written data. And so, going back to the example from the strlen copy manual page, we note that when we have a fixed size buffer with a size being known at compile time, then we can use Sizeof to determine the correct size. But if we have a dynamically allocated buffer, then we can't use Sizeof, because that will always return the size of the pointer on this platform, 8 in our case, which is not the size of the buffer at all. Rather, we need to specify the actual maximum size of the buffer that we allocated to pass to strlen copy. Okay, all of this just about one little operator. But that is indeed what Sizeof is, an operator, not a library function. And it doesn't return the length of a string, but rather the storage size of the data type or expression that we pass it. Now, Sizeof is commonly used during dynamic memory allocation, especially for structs, but it must not be confused with strlen, which simply counts the characters up until the first null byte. So if you are writing data to a buffer that was dynamically allocated, you must know the max size of the buffer and cannot use Sizeof, as that will simply return to you the storage size of the data structure. To ensure you understand the difference between Sizeof and strlen, please look at the sample code posted on the code website and play around with it on your own. Until the next time, and thanks for watching. Cheers!